My name's Naz Shwayhat, and I am the product manager for Brainspace. The primary use cases are acceleration of large-scale reviews and things that are really kind of fall in the what people call document review bucket. So that would be like second requests, and you could even put mergers and acquisitions in that bucket as well. The idea there is that you've got a team of people that has to go through a large volume of data. And when I say data, I mean unstructured content or things that you would have to read, sentences and paragraphs. So Brainspace really is primarily focused on natural human language. That's where we offer all of the value. When you send an email, you have the body text, which is unstructured, right? That's the sentences and paragraphs, whatever you're communicating. And then you have the metadata, which is automatically created when you create the email message, the date sent, who it was sent by, who it was sent to, and that's structured data. So metadata fields, and typically different file types have different types of available metadata. So we can use that structured data in Brainspace to help kind of refine your search results and help kind of filter things, kind of like you would use metadata on Amazon. If you were shopping for a TV and you wanted a 50-inch LED TV from Samsung, you can kind of click through and just filter it down to, things that meet that criteria. And again, like I said earlier, where Brainspace really has offers the most value and kind of offers this kind of magic of machine learning is on the unstructured content. And I'll get into that more, and I'll use the actual product to kind of help me articulate that. With e-discovery and litigation support, a big part of that is document review. And what are review teams doing when they're reviewing documents? They're reading them. So obviously, from a Brainspace perspective, we offered a huge amount of value there to really just trim the amount of time it takes to get through a document review. And with unsupervised learning, it helps you kind of fixate or get closer to the things that are more meaningful and kind of find the signal in the noise. Supervised learning kind of is comparable to the way a spam filter works, where you tell your email client what types of things are actually noise and what things are important. Same concept, right? So you're identifying what a privilege or I'm sorry, what a responsive document is and what a non-responsive document might be. And then you tell the system, you show the system, hey, here's what I've tagged as positive or negative. Now go ahead and score the rest of the documents based on those decisions. So what it helps do is it helps bring things that are like what you've tagged as is important to the top and push things that are not important to the bottom. So get them out of the way. So it helps amplify the signal and de-amplify the noise. The other use cases where I think it gets a lot more exciting, and really what I'm going to demonstrate, is around investigations, specifically internal investigations, and that's where we're seeing an uptick, specifically in interest from the enterprise. And that's essentially when a company is sort of trying to self-police, and maybe they're watching. Maybe if it's a financial organization, they're looking at high risk, employees like traders. They're always looking to get the banks they work for in trouble. Or maybe it's just an HR violation, and somebody has to kind of piece together what happened between two employees. So they're looking at communications, maybe chat, things like that, trying to figure out what happened. Or it could be IP leakage. Maybe an employee was getting ready to exit the organization, and they started sending emails to themselves, to another outside email account. So those are all things that Brainspace can kind of help with. And really, in a broader sense, any kind of disambiguation of large amounts of unstructured data, Brainspace is a great tool to kind of help make sense of that. So it's kind of an overview. So I'm going to go into Enron because Enron is a real data set. It's from the emails that were collected from the Enron matter, back in the early 2000s. And that shows communication. But before I do that, I'm going to go into the Wikipedia data set, which is 4.3 million articles, just because I want to kind of give you some bearings, kind of give you a sense of what you're going to see in an investigation kind of demo scenario. So with the wiki data set, we just thought it would be fun to load it all into Brainspace. And we used certain metadata fields to kind of display time. And you can see here very generic terms show up in what we call our term heat map. So I'm going to kind of walk through each one of these visuals on the dashboard, and then I'll kind of do it again in the context of the Enron data set. So one of the things we do is we actually we call when we ingest data, we call that a build. A couple things are happening. We're building a brain. The brain is basically hyperdimensional is the word that technically describes what it is, but you can think of it as a way to connect terms together based on repeated patterns in the content. And the brilliance of that really, and that's the intelligence. So that is the brain. And it's a separate thing. It's not like an index, like a Lucene index or a DT search index or the index behind the internet. And it's kind of like it's a separate kind of entity that gives you relationships between concepts. So things like football and quarterback would be related based on the repeated patterns in the content that you're analyzing. So what's cool about that is that it gives you a sense of, and the ultimate solution that it provides is that it gives you a way to kind of find things that you didn't know you were even looking for. And in Enron, there's some really good examples of this because they had their own kind of language they were using for all the shady things they were doing. Kinds of ways to describe shell companies and things that they were up to. But in a kind of a broader sense, it gives you a sense of context. Brainspace is kind of equipped to kind of offer this ability to see things and how they're connected and when they're meaningful and when they're not meaningful to whatever your analysis is or investigation is. And I'll get into specific examples of this. So in the context of the Wikipedia set, you can imagine this is a very wide variety of different topics in language, right? So there's a plethora of different topics here, and that's what makes Brainspace so powerful in this example, because I'm going to show you a couple of really cool things you can do in the Wikipedia site to kind of make sense of things very, very quickly. So on the dashboard, we have a few mechanisms here for filtering, but in the Wikipedia set, it's not as powerful as it is in the Enron data set. And we also do something called entity extraction, and I'll come back to this and show you. So that's really what the dashboard is. It's a timeline. It's the ability to filter on unique or original content. I'll get into that a little bit more too. It's this term heat map, which shows you anomalies and kind of fluctuations and things that are kind of maybe high points or things you might want to look at without having to kind of go through everything. It just kind of shows you like these patterns that are outside or deviate from the normal usage of terms. And then we have these facets, which are really kind of what I was explaining earlier. These are the metadata filters that allow you to kind of traverse the data. So you can say, well, give me all the emails that were sent by this domain to this domain. And those are kinds of some of the things you can do here. And then, of course, we have a pretty robust and advanced search capability. Well, what I'm going to focus on with Wikipedia is I'm going to show you the cluster wheel. Now, I talked about what the brain was, right? So it looks at the documents and it says, oh, hey, quarterback shows up next to football enough times that those things are conceptually close to each other, right? Here, what we're doing is we're organizing documents into these groups, these wedges, based on likeness, based on similar words being used. And that's called lexical clustering. And so what's cool about that is at the root level here, we've got these really broad wedges that are kind of things that are generally in the same country. And you can think of that as almost like country, province, or state, city or county, city, neighborhood. Kind of as you move out to the edge of the wheel, you get smaller and smaller groups of documents, or in this case, articles that are more and more like each other. Let me just show you a couple of examples. So if I click on company software, and then I keep clicking out to the edge of the wheel, you can see that what's happening here, game, is these documents that have these concepts here, they're indicators of what is in that larger group of documents. So you can think of it as almost like if I took a warehouse of boxes and each box had a different type of document in them, and then I went around to each one of the boxes and I organized them into piles of insurance documents, medical documents, and then I went ahead and put post-it notes on each one of those piles of boxes. You would walk into the warehouse and you would actually be able to say, okay, well, I'm going to go over here to the insurance documents and I'm going to look in this box because this is where, auto insurance contracts are. And that's kind of what this is, but it's a very interactive, hierarchical, and navigable down to the point where you can kind of, without knowing very much, you can kind of get a sense of what's in your document population without having to read things, right? So at a high level, you're kind of getting a Cliff Notes idea of what's in this pocket. You can also think of it as a map of the content that you're looking at. So you can see here, if I move out to the edges here without knowing any search terms, I'm now in these smaller piles of documents. And here we're seeing things about video games, combat, things like that. And then if I click on this, I can actually add that. And that's going to show me the articles that live in that edge cluster. So again, this is a very broad data set. So what I'm going to do is I want to focus on a subset of data. So we have this mechanism where we can take a subset of the articles in Wikipedia. And I'm going to really quickly just show you how concept search works before I show you this. So I'm going to do a search for Apollo. And you can imagine in the context of the Wikipedia data set, there's a few different ways that this term is used. And the most obvious way, and a sort of the most predominant content that contains the term Apollo, is really around Greek and Roman mythology. And that makes sense. So I'm going to zoom out here, and you can see what it does is it lights up all around the wheel. And that means that Apollo is used in all kinds of different ways. It's used in predominantly, if I go to concept search, I can see Apollo, Polydeuces, Helios, uh, Epimetheus. These are all Centaur. Those are pretty cool. These are all typically going to be associated with Greek and Roman mythology. So what I want to do is I'm going to take my results, and I made Apollo required. I'm going to build what's called a focus. I've already done that, but it only takes a few minutes to do that. And you can see we've only got 15,787 articles when we do make Apollo required. And actually, I think I have a couple here. I'll do it without Apollo being required. I'm just going to do it on the entire 41,000 records. By the way, I made it required. Watch what happens when I just put it back to, I'm going to remove that. So here it's 41,000. So what that means is Brainspace gives you the choice when you're doing a concept search. What it's doing is it's going to the brain first, and it's saying, I'm looking for Apollo. What things are conceptually related to it? And then it's also executing that search against the index. So it's two separate entities behind the scenes. So the Apollo relationships that exist are presented here in my top concepts. But the results here are it's going to show me all of the things that it thinks are most related to the Apollo term. So the results are more voluminous with this 41,000 record set. If I go in here and I say, give me just articles that contain Apollo, that's like doing a keyword search for Apollo. It's saying only articles that contain Apollo. Whereas if I don't make it required, it's giving me things that are conceptually related to Apollo out to a certain distance of relationship, if that makes sense. And I'm going to pause there because that's a little bit kind of a different idea, kind of a different way of people understanding how things are. It's kind of like a loose way of searching for things that are probably going to be interesting to you, but you're going to have to help Brainspace sort of dial in specifically on the things that are interesting to you. It's just suggesting things that are conceptually related to Apollo. So it could be, Rocky Balboa, right? So that could be one of the terms that's at a distance related to Apollo. So what I'm going to do and what we've already done is we've added sorry. We've added all of these documents to a focus that is built just on Apollo. And so if we click on here and just kind of go around, I apologize, my screen here, you can see, probably a little hard to see this. I'm going to see if I can zoom in on this a little bit more. There we go. So this comes back to earlier when NASA was mentioned, right? So look at the root clusters here. What it's done for me is it's broken up these results, and now I can clearly see the different neighborhoods of topics that are related to Apollo. So Greek and Roman mythology, we've got art, we've got Apollo, it looks like some kind of sports reference. We've got series directed, so this is entertainment, probably Apollo Creed, Apollo from Battlestar Galactica, and then we've got Apollo music. There's probably some kind of bands, something related to Apollo there. Now we've got the Air Force, aircraft, and NASA. So now what I can do is say, I really want to know about the Apollo space program. So I'm going to go ahead and add that to my search. And there's 1,930 articles that contain Apollo in the context of the space program and space and NASA and that topic neighborhood. And so it gives me the ability to really focus in on the context of that very generic term that I'm interested in. And that can be incredibly powerful, and I'll use it in the context of the Enron data set as well. And now when I come back to my dashboard, because I'm just looking at this 1,930 article subset of the larger 4 million record Wikipedia set, I can also see the breakdown here. All of these other visuals and things get updated based on this subset. So now I'm looking at top terms for just that 1,930 records, and you can see spacecraft, NASA, astronauts, orbit, Apollo. And check this out. For entities, I can go to entity people, and now I'm looking at things that are, again, linked to these documents here. So Neil Armstrong, Wernher von Braun invented the rocket, Yuri Gagarin, Russian astronaut, John F. Kennedy, all things that are highly related to the subset of documents that I'm looking at. And the cool thing about the entity extraction is this is pulling these out of the unstructured content. and it's creating structured data for me to filter on. So if I just want to see things that are related to the Apollo space program that involve John F. Kennedy, I can go ahead and add that to my search. And now there's 85 records here that mention John F. Kennedy and are really tied to the Apollo space program in my subset. So it's that ability to kind of flip back and forth. And that's a really strong aspect of Brainspace. The user experience is a couple of different things. It's the visuals that impress everybody, but it's also the ability for me to retrieve results very quickly so I can test hypotheses. From an investigative standpoint, that's really powerful because investigators, analysts can kind of go through and stumble through the data and then make these insights and then take what they've learned and come back and plug it in as a search or a filter and change the visuals so they can get a more refined set of results back. I'll pause again for questions or input there.
This is very interesting. Do you guys work like side by side with your clients and like in the discovery process?
Um, we offer, we're not really consultative, right? That's not part of our business model. We're definitely just a software solution sales, you
Got it.
know, but we do have customers that are doing that, and I love to do that kind of stuff. I've worked closely with some of the consultancies and kind of given them different ideas and different workflows. But because Brainspace used to be sold kind of as a sandbox, so you can kind of do all these different things, it used to overwhelm people. So what we did about 2 years ago was we really isolated the 5 specific use cases where you could kind of go through the same beats and achieve very consistent results, and we published those as our workflows. And so people now use those as kind of a baseline and they kind of build on and they say it's kind of like selling a carpenter a toolbox with all the tools they need, but they can build whatever they want. So, all of our customers have access to the same tools, but some of them certainly excel at with their processes and techniques they build around the technology. Okay,
Got it. Thank you.
so that gives you a sense of the wheel and the concept search. And now I want to jump into the Enron data set. I'm going to walk through an actual investigation scenario. I'm going to use those technologies together in a really cohesive way. So I'll kind of tell the story of Enron. If probably everybody on the phone knows it, but if you don't, I'll keep it real simple. Enron was using this really shady way, and people are doing it today. I think we're going to see a lot more of that come out here now with what's going on in the current economy. But there's a lot of this kind of companies buying their own stocks and maybe making these shell companies and hiding debt just to kind of make the share price look better. Executives are bonused on the share price and all that kind of stuff. So they were using mark-to-market accounting and basically realizing profits on things that hadn't even been done yet, and then they were also doing some things on the back end where they were amassing all of this debt, and then they were creating these shell companies that they called the Raptors, and they were sort of hiding some of the debt, selling some of that debt to those shell companies to just further amplify the stock price. So a bunch of stuff they shouldn't have been doing, and there were a bunch of people that knew, and then of course when things started to blow up, everybody didn't know, right? So if let's say I'm coming into the Enron data set now as an investigator, I'm like, look, I don't know very much about what's going on. I don't know this story yet, but I do know this has something to do with non-recourse debt and minority investors, some of these more kind of generic things that I can search for. So why don't I start with that? I'm going to start with the things I do know. So first of all, I don't want to look at duplicative data. When data is collected in an investigation, oftentimes it's collected across multiple custodians. They're typically PST files and mail stores, so the things that are underlying your Outlook inbox. Things like that are collected. They're hard drives, they're My Documents folders, SharePoint. Current collections, obviously there's a huge range of different sources, but most of them at their core are content. So there's a couple of steps that happen before the data gets into Brainspace, and we even have some mechanisms for loading data directly into Brainspace. But let's assume that we've gone through those steps first, and now the data has been collected and it's been loaded into Brainspace, and I'm ready to start looking at it. So the first thing I want to do is I'm going to run a search for one of the main terms that I know is part of this investigation. So I'm going to search for minority investor. It's a generic term. I want to get a sense of what's going on here. Before I actually apply that search, I'm going to filter down to just the unique documents because I don't want to look at redundancy. I want to shrink the footprint as much as possible with what I would call low or no risk filtering decisions, right? So duplicates, don't need to look at duplicates. So I'm going to filter it down to just unique documents. So I just quickly took that 1 million record set with a couple of clicks down to 358,000 records. And I really want to focus on specifically the year 2000. And I'm going to go ahead and now run this search, this concept search against that resulting data set. And there's 121 records now that come back in that range with those two other filters applied. So unique documents and from that time frame. Now the cool thing about Brainspace is, remember earlier I said it lets you kind of test hypotheses. So if I want to trim out the 2000 filter for everything from the year 2000, I can very easily do that, but just by clicking on that search pill, and we'll do that really quickly. So right out of the gate, I'm seeing the things that are conceptually related to minority investor. My attention is immediately piqued by this friend of Enron. It just sounds kind of shady to me. So I'm going to go ahead and make that required, find that, and there's one document that contains friend of Enron that comes back. So I'm going to take a look at this, and very quickly I see that, okay, provides an additional, in quotations, friend of Enron to facilitate short to medium term balance sheet and regulatory solution. Sounds like a bunch of kind of shady business going on here. And this last sentence is what really grabs my attention. That is that ENA would have a requirement that this investment be hedged through Raptor. Okay, I don't know what dinosaurs have to do with this, but I'm intrigued. So I want to now pivot on that Raptor search. And I've got 56,000 documents that contain Raptor. So what I'm going to do now is I'm going to make it required. So very quickly, I've just used Brainspace to go from this generic knowledge of knowing that minority investor is something I want to look for. I figured out that friend of Enron was the thing that was really interesting to me. And from friend of Enron, now I'm looking at Raptor, just like that, just in a few minutes. And we actually demonstrated this for years ago, one of the lead investigators that worked on Enron, and we were talking through sort of the process it took for them to find things like Merlin credit derivative and Chuco SLP and some of these other things that were related to Raptor. It took them months to find this stuff, and we were able to display for them in just a few minutes that they could just kind of click on a couple of things and here are these things. Now, they're not guaranteed to be positive hits or good examples of things that are going to be meaningful, but in this case, they really were. And so it provides a really powerful way to kind of um, see things that you don't know you're looking for very, very quickly. And it really shortens the time frame it takes to kind of gain that knowledge. And then of course you can take that knowledge and expand on it very, very quickly. So now that we're looking at Raptor and we want to know, okay, what's the story with Raptor? There's a few different ways I can kind of pivot from here. So the first thing I want to do is I want to just look at things that contain Raptor because I really want to understand Raptor and only Raptor first. So there's 2,369 documents, and now I want to go even further and say just unique documents. So now there's 875 emails and attachments that I have to go through. The first thing I want to do is I want to go to our communications graph, which this is not using any machine learning. This is just using metadata and creating a visual representation of how people are interacting with each other via email around this topic and just unique documents. And so you can very, very clearly see who the key communicators are talking about Raptor. And Sarah Shackleton and Mary Cook are probably two of the key people here that are going to know what's going on. So one of the things I can do here, what you're actually looking at, it's called a network graph. That's the actual name of this type of visualization. We built our own from the ground up. And the whole point of this is to give you an at-a-glance understanding of who's communicating with who about what, and to give you sort of a sense of who the players are here. And we have two ways you can look at it. You can look at it by people, and you can also look at it by domains that are communicating with each other. So I'm going to flip over to domains. And one of the things I want to really focus on is communication between Enron and VE Law. That's their outside counsel. That's their law firm, Vincent and Elkins. So I'm going to click on that edge. And when I click on the edge, the cool thing about the edge, that's kind of like the conduit of communication between the domains. And you can see what the top terms are that they're communicating. So obviously there's a lot of communication about Raptor and things like that. So I'm going to focus on that by clicking on that and then adding that to my query. And now there's three documents specifically where VE Law and Enron are communicating. And I'm going to flip back to my people view now. And I can see all the people that are involved in communication about that. And very, very quickly, I understand who's involved. So Brent, I think this is Mark Spradling, Sarah Shackleton, Joel Efros, Trevino Maricela. And then we have a couple of people over here talking. What are they talking about? they don't really appear to be talking about the same, they're in a different conversation about Raptor. So I want to go ahead and add that query. Let's see what this email is about. It says, your group to oversee Raptor 3. So they're talking about this Raptor 3 thing. So really, I want to focus on the other one. So what I can do here is I can just quickly remove that, go back to the um, original 3, or I can go back to my search history, and anything that I've been doing here, I can go back to the previous state of the application. So all of that stuff is being kept track of as I kind of move through the visual cues and interact with these visual artifacts. You know, behind all of the things that are happening under the surface, one of the other key things about Brainspace that's unique is that we give you the ability to see the actual the query that's being built. So if anybody wanted to replicate this search, this is the query that you would have to be able to build, but it kind of demystifies it. You know, all the things that are happening behind the scenes in Brainspace, quite a bit of heavy lifting going on, but you don't have to be a PhD in search to be able to achieve these kinds of results. Whereas, you know, if you were to build this a traditional way using Lucene and just basic search techniques, this is the kind of search you would have to be able to build. So it's a tremendous amount of sort of time savings and accessibility, and that's a big part of the user experience that Brainspace offers. It's one of our core competencies is that we demystify a lot of this really advanced technology and kind of hide it behind a really flashy UI. I'll pause there for any other questions or any input. Everybody's blown away, jaws dropping.
Pretty much.
I'm
And all of these people are in
Googling
jail now.
Cheryl Shackleton. Oh no, Cheryl Shackleton she's the senior vice president and counsel of Citigroup Energy.
Yeah, that's kind of what happened.
She did not go to jail.
I don't know that. I think there was a different, you know, like I think there was certain people like Andrew Fastow was somebody, you know, obviously we all know what happened to Kenneth Lay. I think there were some people that were way more accountable than others for what happened.
Mm-hmm.
That's the thing is with white collar crime, you know, to what extent was Sarah just kind of doing what she was told versus, you know, was she really? So I mean, there are plenty of people in here. These are real people, right? And that's funny that you found them. There's another interesting example I can show. It's a little bit inappropriate, so I'm gonna just say that back in the
We
2000s,
don't show this to customers.
yeah, don't
Right,
don't
for
show this
prospects.
outside of yeah, don't show this outside of the
Yes.
company. But what I did was I used an example. So supervised learning, and let me just kind of share, let me just kind of walk back through a couple of steps here because I want to show you. I think back to Raptor, right? When we found Raptor. So when you find a document that you say, okay, this is interesting, I want this, what you can do is you can tag the document either positive or negative. And each one of these tags can be used to train a classifier. So what is a classifier? So it's basically you telling, right? The brain is an unbiased thing that just makes connections based on repeated patterns. But then if you pair that up with you telling Brainspace what you think is important or interesting, and you tag that with a positive tag, and then you tell Brainspace what is not interesting, you can then basically train this classifier and use those things together. You can use this sort of intersection of the unsupervised and supervised technology and do all kinds of really cool things. So in this example, this has been tagged as positive and negative in a few different classifiers, but I'm going to go ahead and just pretend like we tagged a few documents here, and I'm going to jump into the supervised learning interface and show you what this looks like. So what we've done is we've gone through, and this is a great example. This has been 7 training rounds. We tagged 66 positive examples and 17 negative examples. And what we do over time is we start to then, every time I tag a document or a series of documents, I can then rank the rest of the data set. And what it'll do is it'll give high ranks to things that are like what I'm looking for and give low ranks to things that are not what I'm looking for. And then I can use that score to sort of refine my results. So at any point, this is somebody polluted my classifier here. So if somebody just goes in and starts randomly tagging things, that creates problems for me. I should have probably prepped for that. I just didn't think. There we go. This is one. This is one that they built on fantasy football. That's not a good example. Let me find a better one. Jokes. Bear with me for a second here. here, Raptor might work better. Yeah, this is a slightly better example, right? Okay, so this is what we're looking for here. So this is a histogram, and what this shows me is the distribution scores over the entire 1 million record data set based on 370 decisions made. So there were 370 coded documents, meaning that I tagged that many, and only 115 of them were positive, 254 were negative. And after those decisions were made, I built a classifier. And this is what I've got here. So what I have is I have a bunch of stuff kind of in this mid-range. A bunch of stuff.
I don't know if anybody else did, but I lost audio. So after you got the 115, yeah, what did you do after? You built another classifier?
No, this is one classifier, and I've basically told it these are 15 things that are what I want, and here's 254 of what I don't want. And now I've taken those and I've built a classifier and I've scored the remaining anything that falls outside of these tag documents, so the rest of the documents. So, and this is a histogram of the scores distributed over the entire data set. And so what that lets me do is say, I only want to look at things that are more likely to be positive, so I can set a cutoff here. I can actually go in and say trim and give me anything that's 0.85, 85% likely to be what I'm looking for or higher. And I can trim it. And instead of having to look at 1 million documents, now I only have to look at 466. And I can then go through and take action on that smaller subset of documents. So I can build a focus on it. Remember what I did earlier in the Wikipedia data set? I can do the same thing now, but on this likely to be responsive data set. And I can go through and I can even help train the classifier further. I can say, hey, at the very top of the pile, the decisions I make, the negative decisions that I make are more impactful, right? Because they're going to help really amplify the signal and decrease the noise, because I'm going to be decluttering sort of the top of my rankings. So this is where you can kind of create this, what we call augmented intelligence, where the subject matter expert, the investigator, the analyst, the litigation support professional is using this combination of supervised learning and unsupervised learning to really make short work of large volumes of data based on the incremental improvements in knowledge that they're gaining. Does that make sense?
So if they find the data, you brought it down to look at a smaller segment, that 466. If they find some commonalities or similarities throughout that data, does that then give them insight that, hey, we need to look further into that bigger bandwidth of documents that you had before you trimmed it down? Is that usually kind of what happens when you start to look at that smaller segment? Then that gives you what the insights you need to then look at the whole entire documentation or start to tag it differently? Is that what happens?
Yeah, there's a couple of different scenarios here. So in the context of an investigation, the investigators are just going to go as far as they need to get the evidence or to tell a story to figure out where the gaps are. With a litigation scenario, what they're doing is, they're trying to, oftentimes they're just trying to meet a deadline. So they're trying to do as much as they can with as little as possible, time and resources and cost. So what they typically will do, there's two different workflows associated with what's called supervised learning or predictive coding. So they will agree to a certain target statistic up front with all the involved parties that will say that, hey, we're going to give you 80% of the responsive documents, and we're about 95% sure of that. This was created by statisticians, so I apologize for how convoluted it is. But essentially, that's what it is. If you boil it down, it's like we're about 95% sure we can give you 80% of the responsive documents. If you want 100%, we've got to code or review the entire 1 million record set. And a lot of people, they just don't have the time to do it. So there's got to be a negotiation there. So that's what's called predictive coding. More recently, and in the last couple of years, another version of that has taken flight, and that's one that doesn't rely so much on statistical validation, but what it does is, to your point, it actually focuses on kind of a warm fuzzy that you've got most of the responsive documents, right? So it's kind of like this, hey, because we've gone through 8 or 9 rounds of training, because we're seeing less and less positive examples or responsive examples, now we can start just kind of sampling from what's left And if we don't find anything after a few rounds, we have to kind of trust that we've done a good enough job, right? And that's what people typically, there's always negotiation and there's a lot of moving kind of targets there. But that's Brainspace enables pretty much any workflow that you would use supervised learning for in the context of litigation and e-discovery.
Gotcha.
But let me give you an HR scenario with this same technology. So using this same technology, so behind the scenes, what I'm building is a classifier. And if I take a classifier and I want to say, okay, I want to see what's behind that classifier. So I want to see a summary of all the decisions I made. We have this idea that of a portable model. So a model is a distillation of a classifier. What does that mean? So I'll show you because it's just easier to show you. And it really just demystifies this. The lawyers love this because they understand what's happening. It's not some like, wizardry or sorcery happening under the hood. These are the terms, and the higher the weight, the more relevant the term based on the trends that were established during my tagging. These are the terms that are driving scores up. And then if I scroll all the way down, I'll flip. There we go. These are the terms that are pulling scores down. So what does that mean? It means that more documents were tagged with the terms that are at the top here. So Shackleton shows up as a term, so that's a heavily weighted term. West Texas systematically, seismic imaging. These are things that are driving scores up. You can think of them as almost like balloons that are lifting things that are likely to be relevant and responsive to the top of the pile, and then vice versa with the negative score documents. So the cool thing about this is this model can be saved out and then used in another data set. So it's a way for enterprises, it's a way for law firms to sort of, in some scenarios, they can sort of store or save their IP. The result of all of those decisions that were made by lawyers and junior level associates and paralegals can be sort of stored, or it can be used to summarize things on the tail end of the project to give people a good sense of like what types of things were we seeing in those positive decisions. So it's all about transparency. So what I did was I took a bunch of bad words and I just made my own model, right? With all the, boilerplate foul language you would expect to find in an email data set from the early 2000s when people sent when email was an HR nightmare. And so what I did was I built one of those models and I from scratch in supervised learning, profanity, where is it? Profane language. So here is the model. It's been trained and there's a bunch of emails. And so we built one of those. And then we took the top 0.7 or higher documents. We didn't do any other training. We just took a list of boilerplate bad language and ran it against Enron and said, give us everything in the 0.7 or higher. And we built a focus on that because we wanted to see who the main culprits were for using bad language. Oops, let's go back here to analytics. So 70% more are likely, 14,000 records. And so if we look at our com graph, what it's going to show me right out of the gate is the bigger nodes are the people that were participating in more, communication using inappropriate language for the workplace. And this guy here, Matt Lenhart, this guy literally, yeah, he was a potty mouth. I think he was a traitor. And it's funny because he somehow managed a way, and I don't know if I can demonstrate it here, but I think he's literally conceptually related to the term Miller time. So if I'm an HR person and I want to kind of get a sense of like, okay, what has this person been doing? I can take a culmination of all of the things, and I can even go in here and say, okay, what is Matt mostly talking about? I'm going to add that to my query. And if I go to my dashboard, I mean, these are the top terms and this is a mix of all of his email communication in Enron. Like, I mean, thousands, right? This is 923. So these are the top terms: drunk, gonna, strip clubs, and shit. So obviously, Matt might be somebody we need to have a talk with. So this is really powerful, right? But it kind of just is a good example of how portable models can be used to kind of surface those things, right? So inappropriate language, As we move into the future with Brainspace, we're starting to look at things right now. We're actually actively looking at emoji usage, memes, all these things that are happening in chat. So this is emails, and right now Brainspace is really more targeted at emails, although you can load short message formats into Brainspace. But going forward, we're really focusing on taking it to that next level because where Brainspace really shines is human-to-human communication. I'm not saying it can't do a good job with attachments and things like that, but most of the times, the kinds of things that we're looking for in investigation scenarios are really people talking to other people or organizations communicating with each other. It's not so much about the attachments or things like that, although there are scenarios where we found sensitive information that was leaked in an attachment, and Brainspace has been used to sort of identify those things. In fact, if you go to the Brainspace website, there's a lot of success stories. There's actually some real world success stories that we've captured as use cases. They're anonymized, so you can kind of go there and look at those as well. All right, I'll pause. We've got about so I think I've shown you most of the things that are, I think, give you a pretty good understanding of the base technology and sort of how things kind of weave together. But I'm happy to go deeper on some of these if you'd like to.
Does this software live within the system to where it kind of auto-populates, per day or per week or per month, or does it always have to do like a download or upload, I guess?
Great question, right? Great question. So architecturally, we are a software that is deployed on 3 servers typically. We can run in the cloud, but yes, the data has to be dropped somewhere that we have access to. It's a file share. We ingest the data, but there's not a real-time incremental sort of loading of data. And but we are angling towards that, but that has a lot of complications architecturally, things that we have to consider. And our current architecture stack doesn't really lend itself to that type of a dynamic sort of data ingestion architecture. So we are planning to do that, but right now it is a behind the firewall deployed solution. We also can offer it as a sort of a hosted option in AWS and other cloud solutions. So it's typically most of our installs are done. It can even run on a laptop. You can do a 3-server VM kind of configuration that way, but appliances or most of our deployments are behind the firewall and installed, as close to the source data as possible. Any other questions?
Not here.
So some of the biggest misconceptions about Brainspace, just kind of, I'll get it because I know other people are going to be listening to this. So the brain is the concept search. It's what's behind the concept search. So the brain is, I'll do a search for Raptor. Whoops, got to spell it right. There's Raptor. And I'm going to do Toronto and tickets. So I'll make that required, this required, and this required. Now watch what happens when I rediscover concepts. So I can play with the brain without actually executing a search. I'm going to rediscover concepts that are related to Raptor, Toronto, and tickets. And what it's going to do is it's going to give me back the concepts that are related. Now that I've added these other 2 concepts, it's going to give me the things that are most related to all 3 of these. And if I find content, there were some basketball tickets here. So Raptor could be something completely, of interest and relevant to my investigation, or could be harmless, people talking about sporting events. So that's the power of the brain, right? Is I was able to get there very, very quickly without executing a search. I ended up executing a search, but it gave me these other things that were related based on that. And if I want to explore the brain, say I want to go in here and say, remove this, and I'm going to even remove Raptor, and I want to focus on Tatanka, see what's related to Tatanka. Watch how all of these additional concepts change. So what it's doing is it's going to the brain first, Raptors, of course, related, but Black Bay is one of the top one. Place Resources, Heartland Loan. So I can interact with the brain outside of the index before I run the search. I don't actually have to go and find content, but if I did, I could run that search. Now it's going to go and find anything that contains Tatanka. Oh, it looks like oh, that's why, because there it is, 14,000 records, actually. I think I broke something here. The cluster wheel is not the brain. So think of the brain as the intelligence derived from the repeated patterns in the content, and think of the wheel as all of the documents organized into a hierarchical structure that's navigable based on like content, so similar words being used. So you basically with Brainspace have this kind of two different ways that things can be related to each other that you can use in conjunction with each other. And that's I think a good way to make a distinction. And it's something that oftentimes I've heard people when they talk about Brainspace, oftentimes they kind of jumble those things up. So I wanted to make sure that was clear. Cool. Oh, and I'm still looking at the profane language search, so that's why that search didn't come back. There's a root cluster here that has a very interesting label on it. I think one of these days I'm going to run across like Matt Lenhart in a demo scenario or something. I'll be demoing it to him and he'll just be chuckling on the other end of the phone.
Yep, that'd be funny.
Cool.
Thank you so much.
Yeah, this is awesome. Thank you so much.
Thank you.
Thanks. Feel free
Thank you
to
very much.
happy to do it. And if you have any questions, just feel free to reach out.
Good
Yeah,
luck on
thanks. This was fascinating.
Cool. Thank you.